I want to welcome you to League of Women Voters Lunch and Learn presentation of the Pacific Northwest Climate Signals and Actuaries Insights regarding future climate risks and the Inflation Reduction Act. I am Sherry Dysart, Chair of the League of Women Voters of Mason County Climate Change Committee. I want to thank the Thurston and Kitsap Leagues for co-sponsoring this event. And thank you for your interest in this topic and attending today. The meeting will end at 1:30. The presentation has 3 segments with a 5-minute break for questions between each segment. Please use the chat function to type your questions. There are 2 people monitoring the chat, and they will look for questions to bring to Steve's attention. This meeting is being recorded, and the recording will be available on Mason Web TV. Please remember to keep yourself muted so background noise doesn't interfere with Steve's presentation. And now it is my pleasure to introduce our guest speaker, Steve Kolk. Steve is a property casualty actuary with over 40 years of experience providing a wide variety of insurance and financial analytics. His full-time career started and ended in Michigan, where he now lives with his wife, Trudy, to be near their boys and their 5 grandchildren. The best years of his career, 2 full decades, were spent in Seattle, often taking trips into the Cascade Mountains to Leavenworth, where his paternal grandmother grew up. Working in downtown Seattle, Steve was chief actuary at the headquarters of Grange Insurance Group, where he got very familiar with Pacific Northwest risk statistics, that word. After leaving Seattle in 2008, he continued using his love of numbers as chief actuary of CoreLogic, helping them provide property, geographic, and weather risk stats from across the entire United States to hundreds of insurance companies. And he went on to build the Actuary's Climate Risk Index, ACRI, with a North American actuary team. The ACRI is a risk tool for insurers, reinsurers, and government regulators. The ACRI has been published quarterly for the USA and Canada since 2016, and it is being copied around the globe. Presently, Steve chairs the Climate Change Committee of the Casualty Actuarial Society, which continues to improve ACRI. Steve is now semi-retired and president of Calculations LLC, a climate risk consulting firm that solves property catastrophe climate risk problems. The Calculations LLC motto, get Kolk prepared, came from his brother, Jeff, a 2-time national champion Porsche race car driver. Kolk prepared was the motto of Jeff's racing team. Welcome, Steve. Thank you for coming and being our presenter today.
There we go. I was muted. I'm sorry. Thank you, Sherry. It's been a real pleasure for me to work with you to get this presentation ready. And it's a special treat because of the big place in my heart that the state of Washington has, having spent lots of time there. My wife and I still go back and forth. Can you see the presentation?
Yes, we could see it, Steve. It looks great.
All right. Here's my agenda. As you mentioned, Sherry, it's going to be in 3 parts. The first part will be several climate change viewpoints. It's helpful to get your mind and ready to consider different viewpoints. So I'll talk a little bit about that. After that, I will go on and talk about the climate change risk in the Pacific Northwest with a lot of comments drawn from the Actuary's Climate Risk Index I work on. And then the third section, I'll conclude with some climate signals for Mason, Thurston, and Kitsap counties and how they might help you navigate making sense and getting assistance from the Inflation Retirement Act. So here are the climate change viewpoints. I love this little slide. It's French and I can't speak it, so I'm not even going to try. But my point is, you can see the number on the floor. Person on the left says it's a 6. The person on the right says it's 9 or 9 in French. And climate change dialogues often seem like people speaking different languages. So if we translate that into English, it's not that I am wrong because you are right. It's only because you and I do not share the same point of view. I've come across people with so many different views and found it really helps to enter a discussion about climate with patience so that you can understand the many different viewpoints. So with that, I'm going to give you a little background how I went from being a climate skeptic to becoming a climate risk scientist. As Sherry told you, I was an insurance actuary that kept working with bigger and bigger piles of data. Kudos to her for reading my lengthy bio about all that. But climate started in 2008 for me on Leap Day when I met someone, but then I started to get in. I found this science video that I'm going to play from 1958. Trying to get it going here. It's silent for the first few minutes, but it's real insightful. So here we go.
What would happen if we could change the course of the Gulf Stream or the other great ocean currents, or warm up Hudson Bay with atomic furnaces?
Extremely dangerous questions, because with our present knowledge, we have no idea what would happen. Even now, man may be unwittingly changing the world's climate through the waste products of his civilization. Due to our release through factories and automobiles every year of more than 6 billion tons of carbon dioxide, which helps air absorb heat from the sun, our atmosphere seems to be getting warmer.
This is bad.
Well, it's been calculated a few degrees rise in the Earth's temperature would melt the polar ice caps. And if this happens, an inland sea would fill a good portion of the Mississippi Valley. Tourists in glass-bottomed boats would be viewing the drowned towers of Miami through 150 feet of tropical water. Foreign weather, we're not only dealing with forces of a far greater variety than even the atomic physicist encounters, but with life itself.
I trust a few of you on listening saw some of those Bell Labs videos. That was such a wonderful 2-minute summary of why we're dealing with climate change that I thought it'd be a good introduction. Well, when I got in as a mathematician and actuary, I juggled a lot of numbers, and all from climate. I heard long stories about the hockey stick graph that was discovered by Michael Mann, a professor at the University of Pennsylvania. Here is the simplest rendition of it I've ever found. 2 millennia of the average temperature of the globe. So it starts at year 0, and you can see things marched along until 1,000 years after that. They started to get a little bit cooler, and a little cooler still until the invention of the steam engine. And that took us into the Industrial Revolution with increasing use of gasoline and putting CO2 in the air. And that's what did a real turnaround of the average temperature. And you can see in the last just couple decades, it has really accelerated. Now let me take you back just 4 years ago to June 23, 2018. You saw the video from 50 years ago that we knew what might happen from climate. Well, in 1988, on June 23, James Hansen, the lead scientist at NASA, who looked at the warming of Venus and translated that to what might happen to Earth, spoke to the Senate and said the globe will warm. Well, on that 30-year anniversary, now 4 years ago, Axios did this 30-year alarm story, and you can see the globe on the left looks orange with a lot of nice blue spots. They're cool, and it all appears to have gotten red. Well, as a bit of a skeptic, I look at that and say, I play with charts and so on, and I can change the colorizing to kind of tell the story I want. So I started my own investigation, and I kept running up against this hockey stick graph in a variety of forms, and different people have different reactions. Aldous Huxley, I like this quote, "You shall know the truth, and the truth shall make you mad." Well, he also said this: facts do not cease to exist because they are ignored. So I dug deep into the facts. Here again is that 2,000-year graph. Let me just zoom in a little bit, make it disappear, and here you now have the latest 270 years from 1750 to date. And so I took a look at a lot of different statistics for the last quarter of a millennia, 250 years, to see what's happening for this hockey stick graph from 1750 to 2021. And the best source I found was this Earth Honoring Faith by Larry Rasmussen. He put together these 24 graphs of the quarter millennia of history. Half of them on the right are science. The other half on the left are business people. And you can just see visually, they all have that one version or another of the hockey stick graph. And just running them through real quickly, there's CO2 that you've probably heard a lot about, is the things up. Well, there's also nitrous oxide and methane. Then we had ozone depletion, and so that happened. And then the North American land temperature is also increasing. And then we have more and more big floods. The ocean ecosystem is getting more greatly affected. Coral reefs are more and more disappearing. And there are some biologic graphs and the amount of land and forests that's being affected is all showing that hockey stick graph. Well, then if I was more of an actuary, and so on the side of economics, you certainly know that the number of people has risen. That is a more gradual rise, but the productivity of people has that steeper hockey stick graph shape again. And so does foreign direct investments and river dams and water use and city population and our paper consumption to communicate, and the logistics, the transportation and phones that connect us all have greatly increased. And then finance measures go up, and so do McDonald's restaurants. So that pretty much convinced me that that truth that I shook my head about and has made a lot of people mad is something I believe in. And that's why there's scientific consensus, because when professionals look back through 2 centuries of history in every direction, which you just saw, those facts trend and spike like the hockey stick graph. So that got me engaged with, well, this is a real thing to grapple with. Well, then why do actuaries care? Well, that's me. I work in insurance and have dealt with small, regional, and larger companies. Well, here are graphs of natural catastrophes. I did a lot of insurance of properties, homes throughout the Pacific Northwest that led to insuring homes for Ameriprise Insurance Company all across the US. And we had to fund the catastrophes. Well, this is a global picture of the catastrophes in the 80s, put together by Munich Reinsurance Company, which they updated. And you can just see there have been a lot more tiny and large catastrophes. If you look at the US there on the left, you see the brown catastrophes, which are wildfires and droughts. And then the green catastrophes are really the tornadoes and storms. And so the entire globe is being affected by these various catastrophes. I also traveled to find out more about this to the headquarters of the National Oceanic Atmospheric Administration, where they keep the National Weather Service data. And I got to know and work with people who curate an official scorekeeping for the US of the costs of just the disasters in the US that are $1 billion or more. Turns out the costs of the $1 billion disasters, which is what this bar graph shows, constitute well over 80% of the dollars, approaching 90%. So if you just pay attention to the big ones as an insurer, you have something to pay attention to. Well, this graph is just the last 42 years. And if you just visually look at it, what it shows you is the number of disasters. And there were about $3 billion disasters in the US per year in the 80s. Then you look at the 90s, that rose to about 5, 6, 7, sometimes even more. It reached $10 billion disasters in 1998. Then things slowed down in the 2000s, seemed to be about at that same pace of maybe 5 or 6. But then at the end of the 2000s, the pace started to pick up. Those green bars essentially are the severe storms, hailstorms, tornadoes, and the like. And what's not too obvious here until you get into the money is those light yellow bars, tropical cyclones. Those are the very biggest disasters, such as Hurricane Ian that Floridians and others on the East Coast just had to deal with. So anyway, that's the number of disasters. They are now at a pace of last couple of years over 20. And so they've more than tripled in just 40 years. Here's the actual dollars that I, as an actuary in insurance, had to work into insurance rates. In billions of dollars, The 80s saw $182 billion of disasters. The 90s, 300,000, that doubled in the first decade of this century. And it had just crossed $1 trillion in the last complete decade. You can see I've going from the latest 10 years I can get. Excuse me. So that's kind of my quick introduction for what got me involved in climate. I'd love to hear some questions you may have. I will stop sharing so we can see each other and hope to hear some questions from many of you.
Thanks, Stephen. I just want to I know there's a chat from Marty. Thank you that you can use chat, but we have time here. So if you want to raise your hand and ask a question, please do. And don't be shy.
I would imagine our insurance costs are going to increase as a result of all the catastrophes that are happening now, even though we may not live in an area where it's flooding or where we're having severe storms. How will that increase our insurance rates?
That's a great question. The typical rhythm of setting insurance rates for homes is to use 5 years of history. So the actual costs work their way into rates kind of about a 20% at a time, but it takes a while for the damage information to be compiled. So working the costs into insurance rates doesn't really begin until a year or two after the disaster happens. That gives time for the adjusters to deal with homeowners and others. And what I'll show you toward the end is how the state of Washington compares to costs of these disasters. Otherwise, it's engaging with the disasters that really got me involved, and I've become an expert in catastrophe modeling. That's a simple summary. Good question. Thanks.
And Fran, I see your hand is raised, and then Linda Leaks.
Yeah, well, thank you for these really clear and alarming charts. I don't like to look at them, but that's kind of our responsibility. Are you going to get to the question of sea level rise in our area? So I'm on Bainbridge Island, and
I will touch on that indirectly,
okay.
But I won't touch very directly. So let me just speak a little bit to sea level rise. What I've seen is because I've actually measured the melting of the glaciers and found that when the glaciers melt off Greenland and Antarctica, because our globe spins, it actually mounds up in and around the equator. But more importantly for you, because the globe spins, it is pushing more at the Atlantic, and the land is being, it's pushing the Atlantic. So waters of sea level rise pile more up on the Atlantic side, and especially in the Gulf. And the rate of increase is not so much on the Pacific, but
I'm greatly relieved. Thank you.
there you go. Another question?
Yeah, Linda, and then Randy.
I'm curious about what you just talked about on the Gulf, how their levels are rising. Those properties that are there, do they qualify for insurance even if they're so endangered? And is it just out of reach financially, or can they just be totally cut off and say, no, we're not going to insure you people anymore who live in terrible places?
there's a lot of careful protection that goes on there. Flood insurance is provided largely by the National Flood Insurance Program. I'm actually on a committee of the American Academy of Actuaries that looks at all that. Flood insurance, not just for sea level rise, but for riverine floods, is largely in the US provided by that federal program. And they've been kicking. I've actually met the actuaries and been on panels with them, and they've described the rating schema to share the monies as in days past, it was like a 1947 Volkswagen, but just in the last couple of years, that Volkswagen bug of rating for flood insurance on the coast and elsewhere has been modernized with what they're calling risk rating 2.0. It's kind of way outside of what we're talking about today, but that's a great question. And that's one example of how government people and others come together to spread the risk and tackle it. And so we'll move on from that to talking about the specific Pacific Northwest risks. Next question. That was a good one.
So Randy, and then I see Anita, and I know we have one in the chat. So, and then we have a probably, what do you think, Steve, maybe just a couple more minutes here on this segment, and then we'll go to the next.
Okay.
Okay.
Hi, Steve. My own homeowner's insurance company. Sorry.
As human as the rest of us.
I should have shut my phone ring down. Anyway, my own homeowner's insurance company sent me a letter saying that they would do for free, I guess, what people are calling resilience on my home. And maybe you could talk about the actuaries there that have calculated that it'd be more advantageous to them financially to do that free service than absorb whatever claims arise if that service is not provided. And also, some counties have what they call a county-wide resilience program for the counties. So maybe kind of related, talk about if counties spend money doing resilience, how that would save them money over the long run with reduced, emergency calls and fires and all that sort of thing. Thank you.
Two good questions, Randy. On the first one, I've dealt with fire insurance, and for wildfires, it is helpful for homeowners who are especially near the wildland urban interface to clear a buffer of brush around their houses. And so insurance companies are willing to help homeowners with that kind of thing, because clearing a buffer zone around a house keeps a neighborhood from having a series of matchsticks. And so they get the benefit from that. On your community question is another good one, where Insurance Services Office is an old company name now called Verisk, who has put together rating plans, and they compare the neighborhood character to one another, and the neighborhoods are graded, and the better graded neighborhoods get public protection class discounts. And that's worked into the rates. And good question.
Okay, Anita, and then I also just wanted to point out that Evelyn has talked about reading a book, A Walk in the Woods by Bill Bryson, and talks about national parks and the dying of trees, which was written in 1997. So her question is around, is it still a problem for maintenance of our national parks and the dying of trees?
Yes, it is. And God bless the Forest Service for the rhythm of doing that. I've driven through, I remember crossing the border into Montana on my way to moving into Seattle and seeing one of those fires and then seeing the devastation. It's important. I don't know a lot of details, but I know we are blessed by the Forest Service people. So we're ready to move on to the next section.
I had a question.
Go ahead, Anita.
Yeah, how do we in the community get our mayors and city councils to listen to what you're saying? Because I'm afraid that what I've been seeing is that developers seem to have the loudest voices in the city councils, and the climate change issues, like not mowing down all the trees and such, are really not listened to at all. You have any experience with moving mayors and city councils and planners?
I've helped a little bit. I spoke to a group of government people in Virginia, and it really got my talking about climate going. And so I don't have a lot of experience, but I cheer anybody who does. It'd be nice if we could convene. In Virginia, I had the privilege of speaking with all levels of government, including the military. And that was a real treat. And opening their eyes was really helpful, sharing this kind of things I was going to talk about here. So that's a great question. What I hope to give you from the rest of the talk is some things you can point government people to that will help them get educated. So are we ready for that, Sherry, or is there another question?
Let's go ahead and go on with the presentation. We can always circle back if people have more questions at the end.
All right.
Okay.
All right, I'm back in the presentation. And this section, I'm going to tell you about the Actuary's Climate Index, which I helped build when I got directly involved. And this is something you could tell your government people you will deal with. When I was in Virginia, and that was a good segue question. I heard Senator Warner be quoted by John Kerry, now our climate advocate for the country. But he's Senator Warner, who deals a lot with the military, who was on the front lines, says climate change is a threat multiplier, making worse the problems that already exist. And what you've seen hints of already in the graph of the hockey stick is the multiplier. That's what we actuaries do, is measure the multiplier. I had the luck of joining this collaboration of North American actuaries. The organization chart on the right begins with the CAS, of which I'm a member, the Casualty Actuarial Society. We got together with the middle circle there, the Society of Actuaries of Life Actuaries, and the group on the right, the Canadian Institute of Actuaries, all worked in conjunction with the American Academy of Actuaries to say, we have to do something as an industry to tackle climate. We came up with an idea and hired a climatologist. That's Solterra Solutions. And now let me show you what we did. I've had fun juggling these actual numbers. we set out these goals to create an objective index to measure climate changes over recent decades. And to educate the public was one of the goals. So it's a real treat to be sharing what I helped build with all of you now. Whoops. I clicked my wheel, it went a little too fast. We wanted it to be easy to understand, but not simplistic. Easy so that it is simple, government and public can see what's happening, but also complex so it has enough risk meat for insurers to chew on and promote the actuarial profession. Here's what we actually came up with. A graph of the numeric index is what you see on the left, and the places, North America, that we gather data for is what you see on the right. We'll get a little more detail about that as we go. But the blue color we use for colder times, and the red coloring is for hotter times. And you can see the first 30 years were a base period where hot and cold kind of averaged out. And then starting in 1991 was when we had our reference period comparison made, and then we've seen things warm up since. So how we did it was we took a look with the climatologists. They connected us with Environmental Protection Agency measures, and you can see they had three kinds: greenhouse gas measures that I hinted of already, weather and climate and oceans, but the highlighted few, 6 of them were related to the risk to property and homes and vehicles, and that's what we chose. And let me just run them down in a different way now. Because we wanted to see those risk multipliers, we focused on frequency of severity, in a word, that's extremes. So you may remember the bell curve from statistics. Well, we peeled off just the extremes above 2 standard deviations. If I can remind you of a little bit of math, we don't have to go very deep, but we took the extreme hot and cold temperatures, the extreme precipitation, looking at both very wet and very dry days. And then we also looked at extreme wind power and then sea level rise. And here are the 6 indices we came up with. You don't need to pay a whole lot of attention to them here. I'm just going to go through them with some graphs. On the top left, you can see how warm or the hot day temperatures climbed. And to our surprise, there seemed to be about equal as many extreme cold days, in part because something I'll get to in a minute, but then we went on to rainfall and drought, and then extreme wind and sea level. And if you may recall the Frank Capra video, I found this graphic because the first folks in the US that will see sea level rise will be Florida. And it won't be as dramatic as you saw in that video. It'll be more gradual, as you see in the graphic here. But now that you know the 6 parts, let me explain a little bit more detail how this climate extreme index for the actuaries works. If I go back here, temperature is measured in degrees. Actually, and we can't add the number of degrees to the number of days that had drought or the number of days of heavy rainfall. So that was one problem. And then wind power was another scientific measure. And then sea level rise was yet another. So of the 6 measures, we had 5 different units of measure. We did that statistical standard deviation trick. And by turning each of them into a standard deviation, the wiggle or noise let us simply add them together and create this overall index. And it goes from -1 to +2 because that's the range of standard deviations that came out of the mounds of statistics we use. And as I told you, as we started here, below average frequencies of extremes are in blue and above average are in red. And then we had that base period that I hinted at that went from 1961 to 1990. We tried to go back further, but the data wasn't there. So we had these 60 years to work with. And then you can see the individual seasonal noise showed a lot of wiggle. So we literally spent 3 months deciding to do a 5-year average. Hard to believe, but that's what came out. And you can see that light black line that wiggled around during the base period and has climbed steadily ever since. Now let me show you the regions. We divided the US into 12 regions or 6 regions plus Alaska for 7, and then Canada into 5, and that gave us a dozen regions. In bold there, what I'm going to now show you is what we had to call the Central West Pacific region. Funny name for the Pacific Northwest. I prefer that name, having lived there. But when we got together with the Canadians, it was central relative to the Northern West Pacific side of Canada and above the Southern West Pacific in California and the nearby states there. So now let me put those 6 indices together, having taken them apart for the US. I thought I had, I pulled in the wrong slide. I sped through it because I didn't have the, well, see, anyway, what was very interesting when I zeroed in on the Pacific Northwest was to find that you're in a relatively temperate zone climate-wise. I've enjoyed the same thing living in Michigan because the Great Lakes serve as nature's air conditioner. You seem to be far enough from the equator and close enough to the Pacific that there in the state of Washington, Oregon, and Idaho, there's just not a lot of move. There is a little bit. If you look at that wiggle, we'll zero in on it a little while. And here we go. This is just the latest. I'm going to back up. I'm frustrated that I didn't pull in the individual graphs for Pacific Northwest. But this black line, what I do is actually, I'm going to pull out the point for this 2022. And
Hey,
then,
Wes. Hey, sweetie, let me call you back in half an hour.
yeah, and then
Remember to mute yourselves, please.
so the overall US Actuary's Climate Index went from 0.6 in the winter of 2022, increasing just 0.1 to 0.7 in the winter of 2012. And it has increased a real lot in the last decade, now through the winter of 2022 to 1.12. Those are those big black bars, and the red waterfall bars, we call them, as giving them that kind of name, are when things got hotter from hot or more extreme days. And the blue checkered ones are when the extremes became fewer. The first 2 in yellow there are temperature, the hot days and the fewer cold days. And you can see in the 2000s, temperatures were pretty steady, but the climate extremes increased because of heavy rainfall and sea level. But then when we get to the last decade, if you go through those same 6 bars, most of the increase in the climate extremes was from hot days. Fewer cold days contributed a lot. So did rainfall, and sea level rise began to be noticeable. And for the US as a whole, consecutive dry days actually reduced the extremes, and so did wind power. You wouldn't think so with the hurricanes, but what's happening there is there are more big hurricanes and fewer moderate hurricanes. That's the kind of things that facts tell you that you'd never be surprised. Well, now on the same scale, here is the Pacific Northwest. You saw the wiggle wasn't very big. And if we start at 2002, it was 0.14 in the Pacific Northwest. Temperatures cooled it down a little bit. Sea level rise actually dropped a little bit in the West, and consecutive dry days or wildfire and droughts weren't very noticeable, and the wind power cooled things off too. But that has changed in the last decade to where there have been more extreme temperature days. Rainfall didn't make much difference, but the consecutive dry days index flagged that there was something going on. And I'm sure by you living there, you've noticed the increase in wildfires and droughts. Here again is the billion-dollar disaster for the US as a whole. The bar graphs on the left show you the number of disasters, and the simple line plot shows the dollars of loss. And you can see the peaks there from driven mostly by the hurricanes are smoothed in a 5-year average. Now let me do the same thing for the Pacific Northwest, and where for the country as a whole, we're now at a pace of $15 to $20 billion disasters. There's in the Pacific Northwest, only $1, $2, and sometimes $3 billion disasters impact the Pacific Northwest. And what you'll probably like to hear is, on average, the billion-dollar cost has only recently, just in 2020, has the average crossed $1 billion a year. And that $1 billion is being shared between you in Washington, Idaho, and Oregon. And here's the actual decade totals for the Pacific Northwest impacting events. You can see in the 80s, there was just over $70 billion of billion-dollar disasters affecting the Pacific Northwest. That dropped to under 20 in the 90s, came back again to 64 billion in the 2000s, the first decade of the century. And then the last decade, it has tripled to 193 billion, with half of that from flooding and not a little less than half from wildfires and droughts and winter storms and freezing. You wouldn't be. Anyway, that's the aggregate totals. Here's a list that I think might be a little more interesting. Again, this is from the entire US. The biggest drought that hit the US and also impacted the Pacific Northwest was in the summer of 1988. The second was a drought and heat wave in 2012. The third was Western wildfires in the summer and fall of 2018. Those top three were $50 billion, $38 billion in change, and almost $28 billion. And then there was a winter storm in February of 2021 that cost the Pacific Northwest and California and Montana, I think, some 25 billion. And there were wildfires again, and droughts round out the top dozen. Here's the kind of number that I look at as an actuary. We kind of take the average disaster and see what piece of it we fold into insurance rates. And wildfires have gotten worse. You can see tropical cyclones are the biggest. Their average cost is $20 billion, but they can reach as many, as high as $100 billion. The early estimate I have, it's hard to get, but the early estimate for Hurricane Ian is about 75 billion. And and then floods on average cost just under 5 billion a piece. Winter storms are about 4 billion a piece, and severe storms are 2 billion. Severe storms don't seem to be as costly. They're only 1/10, but they rank among the top when you factor in deaths, because tornadoes, you get so little warning relative to tropical cyclones. Tropical cyclones get enough advance warning that people can hunker down. All these estimates here are in 2022 dollars. So that is what I've done with my actuarial work on the large climate disaster events. And so I'll stop here and take some questions.
Yeah, Steve, this is Marty Gibbons. We've got a couple of questions that came in. I'm going to paraphrase them a little bit. Randy Lewis asked, we know climate change has been part of the Earth's environment for eons. Can we determine how much of current climate change is part of the natural cycle versus how much is due to human activity? And a related question is, do other actuary studies refute these findings in this perspective? And who might sponsor those other studies?
I've not, let me take a second question first, because that's more easily dispatched. It's not actuaries so much that do other studies. Other studies may appear to refute them, but I've done comparison of other studies, and it more gets to the issue of, are the records complete in regards to disasters? For the Actuaries Climate Index, we built a risk index that was compiled from Sheldis. There's the resource for the second question. Sheldis is these special hazard loss disaster statistics database. It goes parallel, but it appears to go a little bit counter to what I'm saying, because they aren't as complete. It got started by the University of South Carolina, handed off to the University of Arizona, and I've done a meticulous comparison, and they just don't have as many eyes in the sky or boots on the ground to tally up the disasters. So it is a big data issue that when you ask, is there anything to refute the growing increase? No, there aren't. I've got a lot of confirming studies. Munich Re is the resource I alluded to. Swiss Re is another reinsurer that's done it, and folks in England and Aon. So just all the studies I'm aware of confirm what I've told you. Now let me answer the other question, which was what percent of if I can translate, what percent of this impact is due to mankind? I almost hate to tell you because I doubt you'll believe my answer. I usually ask people to guess, what percent do you think of climate change is due to humankind? People toss out answers like 50%, 70%. My rounded down number is people have caused 115% of climate change. It is because if you actually look at the scientific history, we should be in a cooling cycle. Sunspots are one thing that we're in a tiny cooling cycle, but there's a bigger cycle based on the wobbling elliptical orbit. It's part of the Malkovich cycle. If you really want to search on that, we've done enough heating of the globe that we've undone the natural cooling, completely erased that natural cooling, which would have been 15% less had we not bothered Mother Nature. But I still shake my head. I've heard other people give bigger numbers, so I won't shock you with my other understanding. I'll just leave you with my more conservative number. Good questions. Next.
Kirby would like to ask, does the flooding data include both coastal flooding and river floods?
Yes, it does. I've specifically chosen the $1 billion disaster database compiled by the National Center for Environmental Information because it is complete and it does include riverine flooding as well as coastal flooding and storm surge flooding. And you might also like to know that the $1 billion disaster database, my friend Adam Smith is the climate scientist that curates it, also folds in crop losses that arise, not just losses to property, but they've tried to be real complete. Another good question.
Well, that's all we had for written comments. Maybe we could have one raise hand and have a vocal comment if you like. Otherwise, we can move on.
Is there a written question here? I'm trying to look.
No more written questions right now.
Okay.
So perhaps you could just carry on.
Yeah, let's do that. And then we can circle back to questions as well.
Okay. Got to find my thing to share the. I have two things that are saying, two windows that are saying thing. I gotta get the right one. There it is. Here's the presentation again, picking up from the questions. What I've got for you now is a potpourri of Pacific Northwest climate signals. I started out with climate.gov. That's a website you might want to explore yourself. You can pull lots of information there. It has this nice pair of graphs for the entire US that shows the more severe drought situation of the western side of the US. And they also show precipitation on the right. So you've probably seen the drought map, something like that from Weather People on the left, I don't know. But then the rain map on the right, to me, is very interesting because it shows that rain happens basically west of the east of the Mississippi, and happens a lot, and not a lot of rain is measured in the Rocky Mountains and the Cascades and so on. But there is that wonderful state of Washington that I enjoyed, which has, you know, Olympic rainforest and so on, that's kind of the unique blessing you have that has moderated the climate. This kind of graph shows you how important it is to learn to downscale the numbers. That's a technique I'm doing more and more with mathematics with, but I'll just move on. Here is a zoom in on the US Drought Monitor at the end of last month. It says Washington has been abnormally dry, but the severe and extreme droughts are all south of you in Oregon and especially in California. We're getting back to the Pacific, well, the Actuary Climate Index. That same website from which I get the $1 billion disaster database also has a nice graph of the Pacific Northwest heat wave. Pardon my tongue twist there. I'm sure you all recall June 23 to 28, the US $1 billion disaster website, part of the National Center for Environmental Information. This should be animated. Is it coming? Huh.
It's not moving
I'm
for
not
us.
sure.
Yeah, not yet.
Well, I think I've got a problem on my end and I'm not going to solve it here. But unfortunately, you can't see the heat wave, but I guess I'll leave that as a homework assignment. You can look up the $1 billion disasters in the US and see if you can find this animated map. But that one-day map corresponds to the seasonal peak that I starred there on the left from the Pacific Northwest Actuaries Climate Index. Now let me come back to what I showed you in the second section and zero in on just the latest, mostly the latest decade. This is the kind of map that you can find at the $1 billion disaster website. And what it does is it apportions the individual state losses or the US loss out to the individual states. And you can see the map on the left shows California wildfire disaster costs or disasters are most costly to Californians. And second, I think visually would be wildfires in Colorado. Third, I think in maybe Tennessee. Fourth in Oregon. And then Washington wildfires haven't been quite so extreme. And you can see Alaska even has some. But then drought is a more pervasive disaster, and its costs are shared largely because of the farmers. When we have drought, the food we need frustrates many a farmer, I'm sure, with the interruption to their planting and harvesting. Then I also mentioned flooding disasters. Floods in the state of Washington, Idaho, and Oregon are clearly less severe than other states. Texas and Louisiana are the big ones. Here's some actual, you can see Iowa is a case in point proving what I told you, that the disasters pick up riverine flooding, and so do the other states in and around Iowa. And this is one of those visual tests that confirms that the curation by the National Center for Environmental Information has done a really nice job. The red map on the right mostly picks up the storms from tornadoes, hailstorms, and straight line windstorms, and also combines them with winter storm and freezing events. And that's the state by state look. Now let me just take a quick side jaunt to the Inflation Recovery Act. You'll understand, and then I'll come back to this kind of look with some county level risk maps. If you recall, here's my 250-year map. Before getting to the Inflation Recovery Act, there's this wonderful little video from, I got it fired up again. I had a video from Bill Gates. His basic point is we have the solutions at hand, and let's see, do I have it here? Those 250 years went through first an agricultural revolution, followed by the industrial revolution that created a lot of machines that took power and burned gas and released too much carbon dioxide. Then it went on to the digital revolution that we're largely out of. And the Inflation Recovery Act is, I think we're at the dawning of what I would call a sustainability revolution. And here's the grand challenge of climate change that Bill Gates.
Well, let's talk about climate change. Now, people think, hey, aren't we getting the solar panels and windmills to be a lot less expensive? And isn't that helping reduce greenhouse gases? And the answer is absolutely. But there's a lot more to do than just taking electricity to zero emissions. There's a variety of things that generate greenhouse gases. We have a lot of sectors of the economy, like manufacturing, that are emitting greenhouse gases that aren't talked about as much. Manufacturing, everything we make, even a cute little squishy like this, that's emitting 21% of the greenhouse gases. The number of buildings in the world is going to double by 2060. It's like we're going to build a new New York City every month for the next 40 years. It's a gigantic amount of materials. Steel, cement, wood, all emitting greenhouse gases. We're going to have to figure out how to make all these things in a different way. And so we're going to need a lot of change, a lot of innovation to bring the emissions from all those areas down to zero.
So that's the backstory leading into what was called the Inflation Reduction Act, simply because we're fighting the consumer price index and its measures. But there's $740 billion climate tax and healthcare bill was signed on August 16 of this year. And we finally have a law that will tackle climate change. These are headlines I pulled the day the act was signed. The EPA chimed in with a note saying climate change impacts and risk analysis are something we can help you with. The Hill there in Washington pointed out there are 9 reminders that despite the Inflation Recovery Act, climate change is still a crisis. I think you've seen some of that today from the facts and figures I've compiled for you. And in Popular Science, which I read as a kid, had this story: the Inflation Reduction Act and the CHIPS Act could kick US climate policy back into action. This headline from Climate Central, I think, or no, from CNBC, their climate division pointed out that the Schumer-Manchin reconciliation bill had $369 billion to fight climate change. So those are the places you could go to find the details, which we don't have time to talk about today. But you can go to other sources like ABC that collected some experts to explain things. And Deseret News, I think, might be a good source. if you could find that story. It lays out transformative climate provisions that will bring to the West. But here from an energy.gov is their summary. And I think the point is they've set up billions of dollars to fund loans that can be used to construct sustainability infrastructure. And so that's a provision in section 1706 of the bill. And it has 4 parts. There's innovative clean energy loan guarantee money. So you can make our cities more energy efficient. We can work on energy infrastructure reinvestment to improve the buildings we live in. And then electric vehicle manufacturing is supported by this provision. And not to be forgotten is a $75 million tribal energy loan guarantee program. But then comes the question, if these loan programs office is going to provide these loans to be applied and other funds to build things, you know, so what? I think Nexus Clean Energy newsletter has a nicer way of saying things. The IRA will help tribes to deploy more clean energy, which will be a better financial investment than fossil fuels. And that will come by way of solar panels. And I understand that Washington has signed on with California to shift to allowing only zero emission vehicles by 2035. So it may be sparking a clean energy boom. And that's kind of what little I had time to scoop up for you on the Inflation Reduction Act. Well, my point from all that is people will be clamoring for money. Well, to wrap up here, I wanted to let you know about a new National Risk Index put out by FEMA that is probably going to be referenced to decide who gets this money. And as you can see, I've zeroed in on what the National Risk Index has to say about Mason, Kitsap, Thurston counties, and for good measure, I threw in King and Pierce counties to look at the entire area around the southern part of Puget Sound. So this is a map of the county level National Risk Index in toto. The National Index, you can't see it too well, but I'll just read it for you. On the top there, it is 3 parts, which we'll go through. The risk index is a product of expected annual loss times social vulnerability divided by community resilience. So if we start with expected annual loss, this is what it looks like for part 1 of the National Risk Index. You can see no surprise, because King County is more populous, it has the highest expected loss. There's more people that could be impacted. And then around that, north and south, you have Snohomish and Pierce County and Thurston County are at about the same relatively high level. Then relatively moderate is how I would judge both Mason and Clallam counties. And somewhere between relatively low and very low would be Jefferson County in between there. So that's a look at the damage readiness estimates that are being put together by FEMA. I didn't put any dollar figures in here because this arises largely from Sheldus. FEMA is starting to work with billion-dollar disaster data to kind of improve that. So I just showed the comparisons they can do so far. Had to wet my whistle. Part 2 is the social vulnerability index. And here you can see the least vulnerable counties are Snohomish and King. And the coastal counties have relatively high social vulnerability. This measure came to FEMA from the University of South Carolina, a very good study done there. The last part, I think also coming from the University of South Carolina, is the community resilience component. And there, it's kind of an opposite story. Well, I guess the darker is less resilient. So again, King County, Pierce, and Thurston, and Snohomish have relatively high resilience. Mason, Jefferson, and Clallam would have relatively moderate resilience, and toward the Oregon border is some very low resilience. And I've actually downloaded this report. If anybody wanted to email me, I'd be happy to share the report I ran that I pulled this summary out of. Here's the actual numeric index for those same 4 components. The overall national risk index ranks the King County, Pierce County at highest risk, because money talks. The high population there makes the more ready areas add up to more costs. And there you can see the actual costs from the volume of people there. King County is about over 50% more costly risk-wise than Pierce County, which is, and then Thurston and Kitsap costs are about the same, and Mason County is a little less than that. And then you have the social vulnerability, the ranking from the University of South Carolina is there, and the community's resilience for the 5 counties is really very comparable. So here in the US, we have a pretty high standard of living. And that's a big tool that I would point you to as something to consider. I think people are going to be figuring out how to use this to argue their case and allocate the Inflation Reduction Act monies. And that's all I have for you in my 3rd section. So time for another round of questions.
Well, we have one question from Liz Ellis. What additional restrictions could be considered to improve planning and development in disaster-prone areas, such as near forests and within floodplains?
Good questions. Let me start with
so maybe I can extend that a little bit and say, are the insurance companies, you think, trying to encourage that sort of thing? We see a lot about losses of wildfires and floods in the last few months, and the insurance there's a lot of debate about who should be paying for that. Are the insurance companies trying to do anything and influence this?
Yeah, I can tackle it from the insurance company angle. I'm not I don't work with the Forestry Service or the townspeople directly to build flood, so I can't speak directly, but I can tell you that insurance companies are very careful in how they grade risk. As chief actuary at CoreLogic, I had mounds of data, not just the weather and climate data that I've alluded to here, but they also have mounds of information about the streets and roads, the buildings, and they graduate the risk of the neighborhoods by the kind of vegetation they can see in between the houses. And there are big vendors that get, CoreLogic is probably the best I know of at graduating wildfire risk. But when it comes to flood and the like, there are several different vendors that graduate flood risk and factor that, all aimed at utmost fairness. There's a big push on flood to get more people insured because flood is so costly that only the government has been able to take up the risk. And I was honored to be part of American Integrity and file one of the first private flood programs. But many other insurance companies are following suit in doing that. And there's a lot, piles of data that I've only given you hints of today for how insurance companies are graduating the risk. They do a similar kind of work for tornadoes and hailstorms.
Francesca, any other questions you noticed?
Yes.
Oh.
Can you explain what is meant by social vulnerability?
Yes, I can. I think the thing for me to do there is to peek into, I'm going to quickly share the report. I've got it here. I know there are 10 different facets of society that are compiled. I had it open and I don't see it anymore. Oh yeah, I've got it pulled up here, social vulnerability. I'll just read the description. It measures the susceptibility of social groups to the adverse impacts of natural hazards from death, injury, loss, and disruption of livelihood. And I know it uses about 10 different measures from the Bureau of Labor Statistics. Sorry, I can't give you more detail than that, but that's all I can pull up quickly. Good question.
So if we're talking about social vulnerability, where in the world would you suggest younger people move to to escape the catastrophe that's coming a lot sooner than I thought?
The states of Washington and Michigan.
I knew you were going to say that.
Yeah, I actually sat down and graded the states at risk from high to low, and Florida is at the highest risk. I ranked them, and Michigan is at the lowest, and Washington is very low in there.
Yeah. So New Zealand is some place that people are moving to also, but they've had a lot of wildfires.
Yeah, I'm glad you mentioned New Zealand because they're doing something that the US ought to pick up on, not necessarily needed in the state of Washington, but on the East Coast especially, that's vulnerable to sea level rise. New Zealand has a more complete treatment of insurance by the entire private industry against sea level rise. And they have what they call a very more carefully planned insurance retreat that will help New Zealanders find where to move to, obviously more inland. And you know how big the US, it's a little more complex, but this national risk tool, as it gets refined through the years, it's only a year old, will be a tool to help us decide where to move.
Thank you.
You're welcome. Thank you for the question.
So I
Is
see.
there,
Oh, go ahead.
is there a link to access summarized data relating to tree clear cutting and impact on climate change?
I don't know of one, but I would look at the US Forestry Service. I would start there.
Here's a question specific to this area. Being surrounded by water and ocean, Kitsap County sea level rise may be very real. Are there specific studies regarding the magnitude and time frame of sea level rise impacts to the Central Puget Sound, or are more needed?
Good question. Yes, there are specific studies. I'm sure all of you know that there is also a risk of earthquake, and I mention it in regards to sea level rise because earthquake is known to be a driver of potential tsunami risk. And I really enjoyed speaking at an event put on by the Office of the Insurance Commissioner, where they brought in a couple Indian tribes who have actually put plans together for quick escape routes and places should a tsunami arise. And I would also encourage you to email me and I'll send you this risk report that I compiled that has more details of, I think, almost 20 different kinds of risk that were evaluated by FEMA from the Sheldis data set, in addition to the 7 that are tracked by the National Center for Environmental Information. It will show how the different counties' risk of avalanche and wildfire and stuff stack up.
Steve, this is great. I'm just going to call time here at 1:30, and I'm going to save the chat here. And if someone feels like they didn't quite get their answers or their questions answered, I'll have this to send to Steve, and then we can invite him back, right, Steve? So so I guess I just want to make sure that first of all, thank you, Steve, for the time that you took to prepare this presentation customized for our audience. And thank everybody that came today and that you paid such great attention with great questions. So thank you, thank you, thank you. And again, this recording will be available on Mason Web TV. So I'm going to say good night to everybody. Good afternoon.
Hey, hang on, Sherry. Hang on, Sherry. Hang on.
Yes.
Are you done with your portion?
Of me? Yes.
Okay, I will adjourn this meeting with the reminder that we have the Legacy Forest Hike on Monday, October 24th. Amy reminds us that it's at 11 a.m. The Climate Change Committee meeting is Thursday, October 27th, 2022 at 11 a.m. We have an LWV board meeting on Friday, November 4th, 2022, starting at 12:30. That will be on Zoom. And then our general meeting is Tuesday, November 15th, 22 at 11:30, 2022, from 11:30 to 1:30. Amy's thinking the fire departments, fire districts. So if there are no other business to come before the board, I will adjourn. See you guys next week or 2 weeks from now.